The purpose of today's lesson is to get a little more extra practice with domain and range. What we have to do for the following, sorry about that, the announcements were going. Determine if the graph represents a function, find the domain and the range. Okay, first one. Is this a function? Well, I'm going to use the vertical line test. So all I have to do is draw a line. If I hit 2 points, it's not a function. So is it a function? Yes. The domain. And I'm just going to use interval notation for the domain. The domain starts, and I'm looking at my x's, it starts at 1, and then it goes to the left, so it uses all of these x's. And how could I represent that? Well, it's negative infinity, and it's to 1. Well, infinity always has the non-inclusive, and since this is an open circle, it would be parentheses. Okay, and then the range is what y's are we using. So we're starting up here, and we're using all of these y's. All right, how could we represent that? Well, it looks like we're up 2, and it's going to negative land, so it would be negative infinity, and that would be to 2. Open circle, non-inclusive. And you're always going to write the lowest number to the left first. Okay, is this a function? Can I draw a vertical line and hit this twice? Yes. So this is not a function. The domain is what x's are we using from here on, and this is the origin here. Sometimes that's hard to see. This is the origin. So it looks like we're at 2, and it's inclusive. We include that, and it's positive infinity. The y's. What y's are we using? Well, it keeps going this way forever and this way forever. So anytime that happens, we know it's going to be negative infinity to positive infinity. Okay? Next one, is it a function? If I draw a line, am I going to hit more than 1 point? Nope. So yes, it's a function. Domain. What x's am I using? Well, it looks like I'm using all of them. So one end to the other. So it's negative infinity to positive infinity. What y's? Well, I'm starting here, and I'm only going down this way. So those are the only y's I'm using. And it looks like this is the origin. So 1, 2. So I'm starting at 2, but I'm going to negative infinity, so I have to write that first. And 2, and it's inclusive. Okay. The next one, is it a function? Yes. Domain, here's the origin, 1, 2, 3, 4, 5, so negative 5 to infinity. Inclusive, and from 0 to infinity, and that should have been inclusive. My bad. All right, function, yes. What is the domain? Oh, well, now this is not connected. So the points would be, here's the origin, 1, 2, 3, 4, 5. So the domain is negative 5, negative 2, 3, and 4, 5, 6, 7, 8. 8. And the range is, let's see, 1, 2, 3, 4, 5. So it's 5 and 2. And we would want to write these in order. So obviously 5's the biggest. 2, and then we have a negative 6. Okay. All right. Try number 6 on your own. Okay. Did you get the same answer as I? Negative infinity to infinity and 3 to infinity. Okay. I feel like these next, well, this one I know you can do on your own. So try that one on your own. I'll do 8 with you. This is not a function. Here's your line right here. It's hard to see it, but that's the line. And this is your y-axis here. Y-axis and x-axis. So is it a function? No way. And the domain is -2. That's the only x you're using. That's supposed to be a bracket. And your y is -infinity to infinity. Okay. Is it a function? Yes. Domain -7 to 5, because look at what's happening. We're starting here and we're ending here. So the only numbers we're using are between -7 and 5. The range is from this point here up to here. And that happens to be -4 to 4. Okay, so that's domain and range. Okay, now what we're going to do is we're going to find the missing pieces. Okay, we're going to use this graph over here. What this means is you're going to have an f of x, and that's going to equal y. Okay, well, in this case, x is 0. So what you have to do is you have to go to the graph to 0, and then you look along where x is 0. Okay? And, oh, I think what's happening here is this is being connected. So we have to pretend this is connected, because on my notes it's connected, but you wouldn't know that. Okay, here we go. So these are all the points, and some are open, some not. Okay, now go to the 0 on x, and go up and down until you hit a point. Okay, here it is. This point right here is when x is 0, y is 1, 2, 3, 4, a -5. Just bear with me, keep trying. Okay, let's look at 1. F of 1 equals, what is y when x is 1? Well, x is 1 here, and all of these points are going to be included for f of f of 1 when x is 1. Okay, we're going to erase this line here. We're not going to use that line, okay, because then we're going to get too many options. So when f is 1, it's only going to be at -5 that y is, okay? Now go to x is -5, so 1, 2, 3, 4, 5. What is y? Y is 1, because it's this point right here. Okay? Let's see, 1, 2, 3, 4. Oh, I'm sorry. I should have counted one more. It's 2. It's a 2 there. All right? F is 3, or x is 3. F of 3 means x is 3, what is y? 1, 2, 3, go up to 3, and it's this point here, and that would be at 3. When f is -3, 1, 2, 3, what is y? We're erasing this line too, because we don't want to do, just that one was connected. And at -3, it's -5. F of 5, 1, 2, 3, 4, 5, y is 4. F of -2, 1, 2, y is -5. And when x is 6, 1, 2, 3, 4, 5, 6, nothing. There is no y, so this is a no solution. Okay? The next part is we are given these functions, and we have to evaluate each of the following. So we're going to find f of 2. So we're going to use this f of x, because this is an f. And you're going to take the 2 and you're going to put it in for the x. So instead of x, put a 2 in here, and you're going to get -2. G of 2. So instead of an x, we're going to put a square in there. So 2 times 4 minus 7. 8 minus 7 is 1. Okay? Why don't you try these three. I'm going to pause it and then see if you get the same answer as me. Okay, did you get -7, -18, and 1? Notice these two guys are the same, because when you square a negative, you get the same as when you square a positive. Okay, I want you to try these three and bring these into class tomorrow with these completed. So I call that on your own. We have F, G, and H. This concludes our lesson on domain and range.